Hi, welcome to the breadboard. I have a bit of a mailbag today. A little while ago I had an email from Banggood offering to send me some parts for review. They didn't specifically say what parts I had to have, so I gave them a few items of interest that would lend themselves to some of the current projects I'm doing, and what I've got as a first package from them is right here. So let's have a look at what I've received. One item I can look at right away. The other one is dependent on being built into my CNC motion control project. So we'll have a look at both of them, but one won't be up and running for another few, maybe possibly another couple, 3 weeks or something like that. Got two items in the package. Let's pull them out here. Already opened them because I like to open them before the courier runs away if I can. Anything else in here? Nope, just lots of foam. So we've got two items to have a look at. One of them is a multifunction tester from New. Anyway, multifunction tester TC1. Let's have a quick look inside here. We will go back and do a little more detailed look before the end of the video. So we have a small instruction manual, tells you all about how to use it. It's a color display, and we'll go into more details in a moment. The reason why I selected one of these was because, as you may have seen in a previous video, I had gotten one of these from fish8840.tabo.com via eBay, and about a month or two ago I accidentally knocked it off my bench, and well, the LCD display completely ripped away from the ribbon cable, basically rendering it useless. And for the cost of these, you know, it really isn't probably worth trying to fix it. So when Banggood approached me and offered to send me some parts for review and things, I thought, what better than a component tester and something else, which we'll get to in a moment. So here's the component tester. Let me just zoom in a little bit so we can see better. Okay. So it comes with the instruction manual. You've got the tester itself. Small, it's like about a 1.5 inch LCD display. So you've got one button, looks like you've got infrared, the standard component zero insertion 4 socket for the components to plug into. You've got a USB connection on the bottom and an LED. Is there anything else? We'll have a look inside of this too when we do a little review. Nope, that's pretty much all there is. So the start button, let's press start. So I haven't plugged in any power, but as you can see there, it's starting up in its color. Has a built-in lithium-ion battery. There we go. So yeah, component tester. So now I should be back up and running and be able to identify my parts and what value they are and things like that relatively easily. Of course, resistors and capacitors I can do on my multitude of DMMs, but when it comes to things like inductors, MOSFETs, and various other ones, this is nice to have a quick way to just plug them into a socket and see what the pinout is, and also see if they are basically functioning. So we'll look at that more in a moment. What also comes with this are a 3 colored leads, so that you can drop them in the socket and clip them onto maybe some packages that won't lend themselves to plugging into the zero insertion 4 socket there. And we get some, looks like 3 little crimps that perhaps you can put onto a lead of your own, and a sample capacitor and a sample diode. So we'll try those out in a moment as well. Anyway, that is the multifunction tester we received. The other item here, let me just zoom out a little bit, put that out of the way. Stack of components ready for testing. Is a laser diode module from Banggood. This is a 5-watt laser diode. Now often these are quoted as being 5 watts peak, not average, so I wouldn't be surprised if this actually ends up being about a 3-watt RMS output from the laser diode. And what I want this for is to have it as an add-on module for my CNC project. So I'm going to be building two 3D printers and a small CNC router. Now, one of these I'm going to make multifunction and include the capability of driving the ultraviolet LED laser with it, so we can cut cardboard and maybe some thin foam and balsa wood, or a few things like that, and give it a play with. Now, I haven't finished building those yet. I'm still waiting for a few other parts, so I may be able to power this up and just see what it can do, but we won't really be able to give it the best run for its money until I get it mounted onto one of the CNC machines. So I will have a look at it right now just to look at the build quality and things like that, but a full test will be in a separate video when I've got the CNC ready to mount this onto. Anyway, let's see if we can get this open. So it comes in two parts basically. We have the laser diode module itself, and this, let's just zoom in a little. Okay, so 450 nanometer, 12 volt operation. It's got a serial number, although it's only a partial. It looks like they're probably all B3500. And it's got a focusable lens on the end, which is great. Some of them don't actually have a focus lens on them. A nice big beefy heatsink, fan on the top, some looks like M3 mounting holes for this, so that will help if I model that onto a 3D printer and print out a mount so that it can go on the CNC machine or something like that to my aluminum extrusions that have a 20mm pitch, so a small adapter will make it. So it looks like the second module is a heatsink and DC power module for sending the control signals out to the LED laser module and out to the fan. Now they look like they're also glued in so that they don't fall out and so you don't plug them in the wrong place, because I'd imagine you could blow it up quite easily if you plug the laser diode into the fan output, which is probably just the raw 12 volts. We've also got two other inputs on the other side. One is going to be for the DC input and the other one is going to be for a PWM control signal. So there is no manual for this actually with it, so what we'll have to do is have a look online. We'll go onto the Banggood's website anyway to look at these two products so you can see the price of them and things like that, and see if there's any schematics that will help wire this thing up. I may be able to fire this up just temporarily on the bench. I have to make sure I have a suitable target that it can hit without burning anything in the house. So anyway, that's the laser module, 12 volts, as I said, might be 3.5 watts here, and the power controller for it. We'll look more detail of that in a separate video. Okay, so the multifunction tester, having a quick look through the manual. It has a 160 by 128 TFT display, multifunction key, a transistor test area, Laser Diode test area, infrared receiver window, micro USB charging interface, a charge indicator LED, detection of PN or NPN or PNP bipolar transistors, N channel, P channel, MOSFETs, JFETs, diodes including double diodes, N and P IGBT transistors including potentiometers, inductors, capacitors, thyristors, triacs, and batteries. Automatic detection of Laser diodes from 0.1 to 30 volts. Self-test automatic calibration, infrared decoder, support for Hitachi IR decoder, IR waveform display. So it looks like it's got a lot for the IR going for it as well. 0.01 to 30 volts in the Laser diode test area. So if we have a look at this, you can see here on the top you've got 1, 2, 3, 1, 2, 3, 2 for normal transistor test areas. Down the bottom left here we have cathode and anode, which it must be dedicated for things like Zener testing and things, and then more on the transistor testing areas again here. So maybe I'll see if I can find some Zener diodes and we'll put them in and see what it says or what it will detect. In the meantime, let's give it a quick check for a couple of these test components. So what we got was a red LED, and a 50 volt 2.2 microfarad capacitor. So let's put the capacitor in. Let me zoom in a little bit so you can see the display a little easier. I'll just drop the capacitor into just a random spot. Hit the test button. 2.2 microfarads. It's got an ESR reading of 2.7 ohms, which is probably okay for something that size. It's actually put it up as nanofarads, 2,347 nanofarads, but that's 2.2 mics anyway. So let's take that out and we'll put a diode in here. Hit test again. And you can see it actually pulsing the voltage on the diode, and 1.83 volts forward and 2 picofarads capacitance. So that's pretty good. Let's just switch it around and put it in a different socket. See what it does over there. Shouldn't make any difference particularly. And there we go. So what else I have here is a few inductors that I kind of collect over the times. So we'll see if it can handle inductors. Let's just grab one. So I'm not sure what value this one is, but we'll stick it in anyway. I'll use the bottom left socket, I think, this time. Let's just drop it in. Hit the test button. So 0.15 microhenries at 0.22 ohms. I'm not sure what frequency that is actually reading. Perhaps we'll stick an oscilloscope on there and have a look as well at some point. Let's pick a different inductor. This is just part of a filter for a mains input to an old power supply that I waylaid. Try that again. There we go. So 1.2 millihenries with an 80 ohms impedance. Have I got any other inductors here that'll fit? Yeah, I got one more here. That'll work. Completely different one. This is just a 2-wire inductor. I'll just drop that in. Hit test again. And that's 0.04 millihenries with a 0.09 ohms impedance. So that's quite a different beast. All right, let's try some transistors and things and see how well it behaves with those. What have I got in here? Resistors, diodes. Let's throw a diode in perhaps. So this is actually a 1N4001. So that's a fairly typical standard diode. Let's just drop it across here and give it a whirl. So pin 2 should be the anode, I think. There we go. So 0.643 millivolts, 14 picofarads, not a Zener. Let's stick it in the diode test area perhaps and see if we get something different here. All right, it's testing it as a Zener, but of course it's not a Zener, but any diode working backwards will behave that way at 569 millivolts. Again, cathode and anode. Sorry, anode and cathode according to this one, because it's obviously working in reverse. What else do I have? Let's just grab a 10K resistor. There's 10K 5% resistor. Let's just drop that in there. See what it makes of just a straightforward resistor. So there we go, 10.2K. So it's within tolerance, and I'll verify with a DMM, I think, what that actual value is. So that says 10.2K there. You know, within the tolerance of this little tester. I mean, the multimeter is, you know, several $100s, so that's not too bad. Close enough for what most people would need as a quick test. If you want precision, obviously you're going to use something different. So that's the resistors and things there. Let's see what else I've got in here. All right, I've got an assortment of diodes and bridge rectifiers and MOSFETs in this container. So let's just pull a few out, but let's just drop it in here. And so I've got it dropped in pins 1, 2, and 3. And see what it thinks it is. So N-channel enhanced MOSFET gives me the pin out. Tells me that the VT, which I think is voltage turn on, is 1.97 volts. The reverse protection diode, that's, well, it's not really protection, but it's just a side effect of making these MOSFETs is, I turned off too quick. Got a forward voltage of 564 millivolts. Tells me the RDS on is 0.2 ohms, and it has a gate capacitance of about 2.47 nanofarads. So there you go. Let's try a different component again. Try one of these big ones. I believe these are double diodes. So let's just hit test. Let's see if this identifies it as a double diode or not. Yep, there we go. These are also from switching regulators and things, so they have a low forward voltage. And as you can see here, well, I don't know if you can see there, but see, it's got a forward voltage on both of them of 279 millivolts. Well, 275 and 279 on the two sides. So that's a little double diode device. Let's pick a, I do have a few, let's grab one of these. What have we got here? This is a 2N3703, something like that, transistor. Really old. Don't know whether it still works or not, but we'll put it in and see what happens. Press the test button. There we go. So we've got a BJT, PNP, and pin 1 is the emitter, 2 collector, and 3 is the base. Cool. And do I have anything else random here? Oh, I've got another transistor. I don't know if it's the same kind or not, but I guess we can find out. Let's just drop that in. So the ohms are PNP. What is this one going to be? NPN transistor. There we go. And identifies the HFE as the gain of 27. Base emitter voltage of 691 millivolts, and a collector current of 6 milliamps for that particular test. So that's not too bad. It's deals with inductors, capacitors, resistors, transistors, MOSFETs. Says it also deals with batteries. So let's just grab battery and see what it makes of this. I guess we'll need to use the test clips for this one. So we'll just drop them into pins 1, 2, and 3, and clip the battery on, which one's positive. So I have pins 2 is on positive. I've got a battery, it's charged, I believe. So it's testing, see what it makes of this. So it's correctly identified it as a battery, and it's currently at 4.16 volts, which is probably roughly right for a charged up lithium-ion battery. And it's plus on pin 3 and negative on pin 2, which is correct. So that's not bad. Obviously it didn't identify what kind of battery it is, but at least it will do a battery test. Let's see what else is on these feature list of interest. Okay, let's try the infrared testing. I've got one. Not sure if this has got a good battery in it or not. Actually, let's make sure it has at least got a battery in it. It does. So let's see if it identifies on the infrared. Turn it on, and let's just pulse some infrared in here. And there we go. So that has nicely picked up. Let's just pick, I'm pressing the red button now. Green button, showing us the waveform, showing us the codes. So that is rather cool. I've never seen a tester that actually does that for us before. There's the off command. There's the on command. So that is pretty good, telling us the codes as well as the showing us the waveforms. Very nice. Now what else is on here that we haven't tried yet? So I've not tried the calibration test. 1, 3, 2 all shorted together with this little, maybe this is not for making up your own lead, but maybe they're just providing it as a way of doing a self-test. Let's see. Self-test mode. Okay, I guess that is it. So it's just providing it as a shorting bar. I guess it's a cheap and cheerful way of doing it, but effective nevertheless. So it's running through. Please isolate probe. Okay. Taking that off. So continuing the self-test. This is also a calibration procedure from what I can glean from the short pictures in the manual. Of course, like most progress bars, they're not linear. So self-test ended. Version, I guess it's telling us the version of the software, v2.12k, and that's it. Okay, cool. Let's just turn this off. So the only thing remaining now is to have a quick look inside, see what this thing is based on. The old one that I had before I broke it, that is based on an Arduino, an ATmega 328 microcontroller. It did an actually fairly good job, but nevertheless it wasn't very well protected because it wasn't in a case or anything. So what I like about this one is that it is in a nice case and fairly well protected, and it's using a lithium-ion battery. So let's get the screws out and have a look inside. Now, as I said, this is from Banggood. They sent me these for free. They offered me basically to pick whatever I wanted from their site to review. They just gave me a limit for this particular run, and this one I chose, so there's no payment to do the review. Okay, so let's see if we can get inside this. Taking all the screws out now. I obviously don't want to break anything, so okay, lithium-ion battery is glued to the back surface. See if I can gently prise that off. Yep. There we go. So it's a 890 milliampere hour 3.7 volt lithium battery. That's not too bad for something like this. So let me just try and set this up a little bit so you can have a closer look of what's in here. Certainly not your usual testing stuff. I might even have to get the macro lens on this. Okay, so battery charging circuit down here by the look of it. That's the USB connection. I'm careful where I touch because this is obviously still connected with the battery. Charging LED. Got a little inductor here. I would imagine that is probably going to be used for testing the up to 30 volt Laser Diode. So I haven't managed to find one yet, but I will have a look. We're using an ATmega processor here. Let me just get a magnifier or something so I can see what kind that is. Excuse the little thing here. That is an ATmega 324. Okay, a little unusual, but that's what that is. ATmega 324 PA. For those that want to have a look it up, that's what you've got. 16 megahertz crystal. So I've got the ATmega processor here, 324, 16 megahertz crystal. Can't see a part number on there. I think it's one of these generic blank things. It looks like a transistor here, a bunch of passive components, and this inductor, which is probably used to generate the higher voltages for driving the Laser Diode tests. So let's see if we can get this board out and have a look at the other side. I think I have to be careful because the LCD display is also, oh, there are more screws. That would help if I take those out. Okay, so there we go. So I'm just trying to see, there's nothing whatsoever underneath the color LCD display. We have the zoo insertion for socket, standard little yellow push button, and there's the infrared receiver. It's one of these built-in, takes a 32 kilohertz signal, which is the normal the normal frequency, if you like, carrier frequency of the IR, most IR signals, and converts it down to ones and zeros. So the first level decoding is built into the IR receiver here. So the microcontroller only has to deal with the sort of like the actual true logical ones and zeros, not the carrier frequency, which is rather cool. So there's our ZIF socket connected here, and as I said, I'm pretty sure that's going to be generating the voltages necessary for testing higher Zener diodes and things. And that's pretty much it. Looks like there's a couple of components not populated here. For instance, over here, don't know what would go there. So it looks like there's potentially options for other things on here. We have another header here, which might be for programming. It seems to all head down to the CPU or the microcontroller, so maybe different options for displays and things like that. But anyway, that's pretty much it. So we'll have a look online, check the price, but all in all, no bodges that I can see or anything. It's quite a nice little build. So anyway, let's go over and get to the computer and have a look at the price and any other information that may be available. Before we go on and look at the website, I just wanted to show you a couple of waveforms that I captured on my Keysight DSOX1102G. The one we're looking at right now, I put the scope probes across a 270 or thereabouts microfarad capacitor, and as you can see here, it's using the DVDT measurement process to actually calculate the capacitance. It's not putting an AC waveform in there or anything like that. It's simply using an RC circuit and timing when the voltage gets to the, I think, 63% threshold. It's usually 5T when you start calculating the time constant of an RC network, which is where they deem that the signal has reached relative stability, and they use that as a calculation to figure out what the capacitance is. Of course, that's a static measurement, and at different frequencies it could behave differently, but that's how this device seems to be doing the measurement. So for an inductor, I found this kind of waveform. Now obviously the inductances that I was testing were quite small values, and if I zoom in here you can see it looks like it's a series of pulses. I think that's zoomed right in on one. I think it's using a similar technique. Oh no, sorry, this one is a 2 microfarad capacitor, so the edges are much faster, but it's using the same technique. When looking at the inductance values for the measurements, I think it's using the same technique, but the rise times are much faster with the coils that I was testing. So yeah, if I go back to these, that's the large value capacitor. Obviously things get slowed down quite considerably, so it's much easier to see what is being captured. I didn't want to spend too much time trying to figure out the inductor waveform. It was quite noisy, and it seemed to be very evident that it was using the DVDT with the inductor as well. So basically a resistor and an inductor in series with it, but using the same technique as you use with a resistor capacitor to measure the capacitance by measuring the rise time, etc. Anyway, let's get back to the website. So here we have the page for the Multifunction Tester TC1 that I received from Banggood. You can see here that the price is $40 Canadian, but yeah, so $40 Canadian, $29 US, and it gets you one of these testers. Now I've found that this tester has actually behaved very well. It does get a little confused if you put the component in the wrong place. So putting a resistor or something in the diode test area, the Zener test area, is going to always think it's a Zener diode and give you false readings. So if you don't know what the component is to start with, put it in one of the connections labeled 1, 2, 3. Make sure the component isn't put between a 1 and a 1, because they're all joined together on the circuit board. So it needs to be between 1 and 2, or a 2 and 3, or a 1 and 3. in order to measure properly. And of course, if you're using a diode or either a Zener or a regular one, then you can put it on the AA and K terminals to get a better reading for the higher voltage Zener diodes and things like that. It seems to be reasonably accurate for $40. It's a great little tool to have in your test bag. It does quite a range of components, as you've seen, and surprisingly will even do the IR. That was something I've never seen on a tester before. So all in all, I was quite impressed with it. And I think it's quite an improvement on the one I had before. The fact that it's in a case as well means it's very well protected. I think if I drop it, it's not going to rip the LCD from the board this time. I'm not going to test that theory. I just like to think it's a little more robust. So that's good. For the laser that I got, this is the page for that. Its Canadian price is currently $131. This is a 12 volt TTL modulation, 3.5 watts blue laser, so 450 nanometer. It's in the ultraviolet kind of range, so you really do need to have protective glasses when you're working with this. You can't just use the clear ones. When you're using a CO2 laser, you do get a certain amount of protection even using simple acrylic glasses, because acrylic is completely opaque to CO2, like up in the 1800 nanometer range, whereas at the 450 nanometers it isn't. It's basically transparent, so you do need to have ones with the correct filter in the lenses. I did quickly power this up on the bench just to make sure it worked, but I'm going to, and it does, it can actually focus to quite a range away from the head. I need to get a better power supply though, because my lab bench power supply only goes up to 1.5 amps, and this requires 12 volts at 2 amps to run at its full capability. It will actually start producing a laser beam even down at about 6 volts that will actually burn something, but it's more burning and setting something on fire than cutting, so you want to have the higher power if you can. As soon as I've set up a proper power supply and I've got it onto my CNC machine, then I'll be making another video for it. Here's the basic specification. So wavelength 445 nanometers, blue laser module 3.5 watts. You can focus it as close as 0.5 millimeter, but I think that because of the angle of the focusing beam at that distance, you would not have very much depth of field. So if you were trying to cut through something, it would have some very slopey edges on it, I would think. When you focus a bit further away, the beam is going to be nearer parallel. It never will be parallel because you're focusing it, of course, but it will be nearer to that and will give you a better edge. But once I've got it set up, we will do some more testing. It has a TTL input on the control board so that you can pulse width modulate the laser beam, and as it says here, anything up to about 20 kilohertz was what you can use for the modulation frequency. So the nice thing is, if you start modulating between 0% and 100% ratio of on and off, you can control it, and just because a lot of these things work better if you leave them at their maximum current when they're on, same as just a regular LED that you use for illuminating your under-counter lights in your kitchen or something like that. Anyway, I will provide the links to these two locations. There will be a future video for the laser module once I have it mounted into my CNC router. I've got a video to make wiring up the electronics first, and we will deal with how to hook this into a motion control system, both the Mark III motion controller and also a couple of the potentially 3D printer controllers that have a PWM output capability, because a lot of the new software supports laser mode, so we will look into that and hook that up to that as well. You can see here on the control board, this is basically a constant current control board. The two potentiometers, and they're not labeled as to what exactly they're doing, but they are sealed so that you can't adjust them, or at least there's an attempt to seal them so you can't adjust them. You have the white connector here that is for the main bulk 12 volts 2 amp power coming in, and this blue connector is so that you can apply a logic level pulse width modulated signal. On the far side you've got the white connector, which is just 12 volts going to the fan, and you've got the blue connector, which is the constant current output to the laser diode itself. Now, do not get these mixed up. If you put 12 volts straight across the laser diode and it's not regulated to limit the current and everything else, you will probably fry the laser diode. And that will be an expensive mistake to make at, over $100 for this. Like any laser, it is very dangerous, so be careful of your environment when you're using this. You need to put appropriate safety measures in place, i.e. Glasses, and then even when you have it on the CNC machine, you would need to put shields to minimize the amount of laser light that could potentially be reflected out towards anybody that's standing nearby. Make sure you have extra pairs of glasses and things to protect any visitors that might be in your workshop. And I think that's pretty much it. Yep, I think that's it. So if you like that, give me a thumbs up. If you didn't, well then don't. As you may have noticed on my other videos, I am starting in the process of doing a series on motion control, and I will be using this laser module as part of my 3D printer, CNC router, laser cutter kind of builds that I'm doing. I'm actually building up 3 machines in total. 2 of them are going to be 3D printers, one's going to be a Core XY, one is more traditional build, a bit like a Prusa i3 Mark II, and I have a smaller CNC router build that I'm also just in the process of completing. Mechanical build is done, and I'm just putting together the electronics, which have been the subject of a couple of previous videos. Anyway, that's it for now. See you again soon. Bye.